Okay. Hello, everyone. I'm Laura Schultz. I'm the head of strategic development and partnerships at LRZ, the Leibniz Supercomputing Center. And it's my pleasure today to tell you a little bit about what we've been up to at LRZ lately. Now, I'd like to start with a presentation 101 tactic and start my talk off with a quote. But this is from a famous Bavarian that I'm sure everyone here is familiar with, Werner Heisenberg. Professor Heisenberg commented that, basically it's not a good idea to bust things up, that to separate parts from the whole because the parts together are its reality. And I like this quote because it reminds me of how we operate at LRZ. And I think it represents some of the directions and choices we're making on our roadmap with the services and resources that we are offering for science here. And so I'd like to take this idea and try to weave it through as a red thread in my presentation today. So let's see how that goes. So to get started, for some of you that might perhaps be unfamiliar with LRZ, we're located just north of Munich in Germany, in southern Germany. If you're perhaps also unfamiliar with Munich, then you've probably heard about the big party that we throw the whole world every year. That's the Oktoberfest. So I think if you can remember big party, beer, and supercomputers, that'll be enough to get you oriented to LRZ. This is our facility here. This is our double cube on the left side. And then this is our office space, visualization center, meeting rooms, and training facility. So we are celebrating 60 years next year. So that's a big milestone for us. And that we is me and 260 colleagues. We have a board that consists of four professors from two of the main universities and the big universities in Munich. That's the Technical University of Munich and the University of Munich, the LMU. So that'll become relevant in just a second. But that kind of comprises a little bit of who we are and what um, and where we are. So now, kind of drilling down just a little bit into this, again, I mentioned about TOOM and LMU. These are our two main users. So we are a university supporting research computing facility. This is a fairly big space, these two universities together, 110 students, 30,000 employees, quite large. Munich itself is really a hotspot of thinking and scientific prowess, a headquarters of the Fraunhofer Society, Max Planck institutions, Helmholtz are in this space as well. So there's an awful lot of brain power here. And these two University of Excellence have quite a big demand for on us and what they need from us in order to innovate and excel. Now, expanding that out just a little bit more, we don't just serve those two universities, we serve many universities and institutions within the state of Bavaria. We serve science users in Germany as part of the Gauss Center for Supercomputing, GCS. And we also service science researchers Europe wide through PRACE and through Euro HPC. So a very broad spectrum of users, different nationalities, and different regional locations. Now, I want to come back to this parts of the whole idea and kind of drill a bit on that. So, in order to do really good science, you need a lot of different parts in your portfolio, right? And that includes everything from the supercomputing systems that I'm going to talk about, obviously, in a bit. It includes data storage. It includes moving all of that information on our high speed networking infrastructure, our Munich Scientific Network. It includes being able to visualize and manipulate that data with our virtual reality and visualization center. All of those components together, including everything from your email, your training and education courses, etc., all of that's bundled together. Those are the resources and services that we offer, but we also are active in researching and developing new capabilities to be able to offer our users. And in particular, one of the things that we've brought up in just recently, is a future computing group where we really look to explore future architectures for AI, big data, quantum, et cetera. And we do that in partnership with several of the Bavarian universities. Okay, now, user groups also have different flavors to them, right? So, as an academic center, um, supporting academic center, we have a broad swath of domain spaces and workloads that come to us from quantum physics, astrophysics, through anthropology, social sciences, in between chemistry, geophysics, CFD, etc. So, it's a very broad band there of domain spaces. And in each of those domain spaces, the level of expertise varies, right? From early users to more matured users to more demanding users. Different cultures and behaviors prevail. We're seeing this right now. I'll get to this a little bit later, but we're seeing this right now in the quantum space, working with them more closely, and just the difference in vocabulary between HPC and quantum users, and trying to find that common ground between us. um, Different requirements on the hardware, different needs, different behaviors on the software stack. So all of these dimensions, all of these parts, all of these faces of the cube, we have to take into account as we're attempting to define and provide for these users. Um, Again, kind of going into the traditional HPC ecosystem and what that looks like now. Um, we have our traditional mod sim folks, what this computing was designed for initially. They've been here in this ecosystem for a while. They're nice and comfortable. We have getting ever bigger volumes of data that need a home and need to be crunched. And so we're now thinking a lot more about big data workloads. We've got the machine learning and AI crowd that are coming in, finding a seat, have made themselves at home. And then we've got the quantum computing and those workloads and those users who are coming into this ecosystem, checking around and finding themselves a comfy place to sit and to utilize this space. So we have a lot going on in that dimension. And then another component to be thinking about here too is the user segmentation within different groups. So this is a little exercise that we did in the HPC space once, where we just tried to think about our users in different pathways. We've got the clickers who are not going to be too close to a command line. We've got librarians who are going to change out libraries, but that's probably going to be about it. Directives that might do a little bit of code change, power users, all the way up to, I call the bare metalheads that really just want to get access to the big iron and get out of their way. And we think about, for each of those segments, how can we make it faster? How can we make it easier, smoother? How can we get them to their science better? And how can we support innovative science for each of them? And again, we feel that responsibility with the Bavarian ecosystem and the excellence that we have here. How do we help continue pushing that through what we're offering and what we're doing? So that kind of brings us to this, wrapping up this parts of this whole idea. We've got domain diversity, user diversity, workflows, different types of software, culture of different types of software. I didn't even get into the hardware diversity, but we all know about the Cambrian explosion and the various CPUs and GPUs and FPGAs and ASICs and all of these components, all of these parts. We need to think about how we're bringing them together, and how are we designing a service portfolio, a resource portfolio, and how that drives the decisions for acquisitions and for the research and development investments that we put in order to help our users advance their science and their ability. So, we think about this, and we're driving ever more in this direction to think about, application co-design as a service to science. We think about that in three different ways, or three pillars. One is to genuinely understand the workflows better, to take that information from our users to have a tight coupled connection with our vendors, working together to design solutions, and then really thinking about how the software works in harmony with all of that. How are we bringing all of that together? So, to the first point, so I have a marketing research background, and the mantra was always, know what your demographic ate for breakfast. And that applies 100% here as well. So if you're getting a little anxious looking at this picture, this was pre-corona. This is a community outreach initiative that we started about 2 years ago for our quantum computing environment and user base. This is the Bavarian Quantum Computing Exchange. And this has been a really great exercise for us, I have to say. Every month, we have brought together our community. We have brought together the biggest companies and researchers that we can get a hold of and convince to come talk to us. And with that, our community is getting exposure. We're getting the tech scouting component that we need. We provide this as an opportunity for our community to learn, but also to network together. And then after a period of time, we used it to start using our community to help us evaluate. So as we were attempting to make decisions for investments, we had members of our community come with us and the vendors, do demonstrations, do tech assessment together, and determine what was really the best pathway for the community and for their needs at that time. Also, we've released surveys to really think about what their needs for the future are going to be so that we can really try to design that portfolio and meet their needs. So we do this for quantum, but we also do this for our HPC space, and we're starting to do this for our AI space with more intensity. So really understanding our users and that working together. And now for the other two components, the working with the vendors for the hardware component and the software component, I will start with the obligatory beauty picture of Super Mook NG in all of her blue and yellow glory here. So she is number 15 on the top 500 still, so very respectable. An Intel and Lenovo system. This has been in service since 2019 and has produced really great science for us, and will continue to do so for several more years. However, as we all know, that once we light up a system and get it going, we're already thinking about the next system, and that very much is the case. SuperMOOC NG Phase 2 has been recently announced. It's again an Intel system with Sapphire Rapids CPUs and Ponte Vecchio GPUs, Deo storage, and Optane memory. Also, a Lenovo is the OEM for us. So we're very excited to have this system come in, and it represents the continued evolution that we are experiencing together with our users more into the GPU space, obviously. Now that's in 2022. Already, we have GPU systems in house. We've got several DGX A100s as part of the Munich Center for Machine Learning. We also have an AMD system in with MI50s, and then we'll be looking at others as we go along. Now, that's the next system. We're already thinking, obviously, of the next system. So this is in the mid 20s. We are looking at our exascale class system. Our code name is Examook for this one. And again, it comes to the same question: how are we going to take all of these parts together, all of these elements, and design a system with the money that we have and and the energy that we have? How are we going to put all of this together? So, thinking strategically about how we're going to approach this, we've come up with our approach, which is an integration approach. And I'm not going to go into a lot of detail about this because we released a paper about this not too long ago, and the URL is there on the slides. The basic premise is pretty simple, the storyline, and it's one that we all, I think, know and are familiar with. We have power and energy limits. Um, we have them, especially as we're thinking about very large scale systems. In Europe, we have the added dimension of very, very expensive energy, and so we really have those power limits that constrain how we proceed and at what scale we can build. Now we can go to specialization, of course, um, and that's definitely an option. But we've got the limit of having diverse workloads. So we have to have not just one specialization, but many specializations in order to accommodate those diverse workloads. Okay, so that's fine. You can have them all side by side. But then the last component of it is the data movement, which is also very expensive in terms of energy. So we have to think about how we deal with the power and energy limits, how we specialize many times over for the workloads that we have, and how we keep the data close and not move it around too much in order to meet all of these conditions. The hardware is part of the story, of course. We also need the software that is buttressing and supporting all of that. So we need a production ready software stack that gives us that low energy conditions that we need for these high performance systems. And so to that end, we've got two projects, European projects that we're working in and part of right now. One is Regala, and that is a resource manager that's power aware, right? And the deep sea component of this project is the software stack that's utilizing the resource manager. So we're actively working on those components together, building on what we've already done at LRZ with our DCDB and our Wintermutt work, putting that all together and thinking about this in a holistic, integrative approach as we move forward. In order to do that, we're going to have to do some experiments. And so, one of the things that we've done in the last year and a half, I think, is stand up the Beast. So, this is the Bavarian Energy Architecture and Software Testbed. And our mascot for Beast is a Bavarian lion with Bavarian blue eyes, because Bavaria. This is a really great system, and it's proving to be quite useful for us in a couple of different dimensions. One, we have a nice diverse portfolio in there of CPUs, GPUs. We've got the FPGAs. We're working on adding in more ASICs into this. This allows us to increase our in-house knowledge and our ability to evaluate through various structured experiments, our hardware, various software stacks, etc. And it really, the point of this is to help us make smarter decisions when it comes to procurement time. It also helps us to better design our overall resource portfolio. And what's the biggest component? What's the flagship? What are the secondary systems? How does this all work together? The other thing that's been proving very beneficial for the academic researchers, is that they can come in and take parts of their work, parts of their code, run it on a couple of the different systems, get a preliminary idea what works best for them, and also gives us some insight from our user community about where we might want to think about going in the future. The other nice thing, again, with these universities of excellence, with TUM and LMU, we have a joint university beast lab that we've set up that I think we're now going into our third lab, our third semester. And this really puts these advanced architectures in the hands of students early on, or in their careers, to allow them to experience this, to evaluate it, to make comparative studies between them, and to really get a sense of the supercomputing space. And this has been really great, not just for the follow-on bachelor's and master's programs, but it's also triggered some people who want to do PhDs with our related chairs. And this has really been a very nice work pipeline development. initiative. So if you're interested in a little bit more than that, Dr. Josef Weidendorfer is our head of future computing and can answer more questions about that system for you. So the foci of Beast, right? This from the data center to the user, we need to think about the energy needs that we have. What can we be experimenting with early on? What can we be testing? Obviously, we're all thinking about the programmability, the portability of if we've got various architectures that are going to continue to evolve as we go forward to make sure that we can port these codes and make them useful and not dead on arrival with new systems. And then really just focusing overall on the usability for the end user, but having that really tight relationship with the user in order to be able to do that. So that's kind of the experimental side on the HPC space. Now I'm going to even go more experimental and tell you about what we're doing with quantum integration into HPC ecosystems. This is a new area for us. This is a flag that we're planting in the ground that we're trying to really understand QPUs as a new class of accelerator for HPC systems. And we're thinking about this again holistically. This is one part of the whole. So we're really thinking about the challenges that we're facing for the hardware, the software stack, the programming models. We've done a lot of early work with community outreach and alignment. We've had a series this spring of think tanks with several representatives from centers around the world, where we've had up until like 2 a.m. in the morning, because we've been accommodating to different time zones, these really great conversations that we're working into a white paper right now. We have an IEEE Quantum Week workshop. So this is our WIP QC 21 workshop, and there's the URL for our workshop. If you are interested, we are still actively taking submissions. So please, if you have somebody who might be interested in contributing, to check out our website and submit, because we think this is a really important area, and we're really looking forward to some active and vibrant conversations as we move forward in some work. Now, we are part, LRZ is part of the Munich Quantum Valley, which is a very focused and intense local effort to build up quantum capabilities within Bavaria. And as a member of MQV, we are working particularly on integrating, on building up and integrating HPC QC software environment. So we are building up all of these various components, the programming environment, the runtime. We're also looking at the actual microcontrols of the systems, and actually how to integrate them with HPC systems and cloud systems. So this is work that is really starting to kick off right now actively. And the first big project that we have in this space is the DAC project. This is for digital analog quantum computing. This is a federal BMBF project that just started this year that runs through 25. And one of our, you'll see our several partners there. Our biggest partner is IQM, which is a Finnish German quantum computing company. And the idea of DAC is to extend the concept of quantum computing to these application specific cases, to build up the system and the capabilities up to about 54 qubits, and then to actively work towards integrating the cryostat and HPC systems together, and with the software stack buttressing the two of them together. So this is ongoing, and I can also say that we are in the process of a project that will look at integration of quantum for an exascale class system as well. So a lot of activity going on in this space. Now, pulling back just a little bit and going a little bit more general, all of this is part of another big activity that happened this year in March. We opened our Quantum Integration Center, or the QUIC. And the gentleman in front, is our governor of the state of Bavaria, Minister President Suter. To the left is our science minister, and then to the right is the director of LRZ, Dieter Kranzemüller, who will probably be familiar to many of you. So the Quick has two major directions. I already covered that HPC quantum computing integration R&D component, but we've also have set up and are growing our quantum computing services. Our quantum team really started getting populated this year. Our head of quantum computing, Luigi Ipicchino, is actively hiring. We actually have jobs. So if you like quantum computing and I guess also beer and big parties, you can also check out our website for some of the jobs that we currently have available. But our resources for the Quick and our portfolio for that really comprise of several things. So we're looking at actually having on-premise systems with the DAC project as one of them. We've been designing and customizing and fitting lab space and working on cryostat procurements. We have several future research projects that are going to be defining some more on-prem systems. We are looking at practical quantum services. So we're working on remote access to various technologies and topographies for our users. Working on workflow optimization in various elements. On our supercomputing system, we have the Intel IQS on Mook NG. We also have simulators in terms of the Atos QLM system. And then, of course, we've got our user community and feedback loop and education portfolio. And I had already mentioned the BQCX before. Okay, so bringing all of that together again, I'm going to return to this concept and with this diagram really bring home this point about the parts of the whole. So we think about our users and what their needs are, and we constantly working in constant feedback with them, and we're always very interested in working with other centers who and seeing what their user management model is and how we could ever improve that process. So I'm always very interested in forming partnerships with other HPC centers on this sort of topic, taking those users, what they're doing, giving them access to new technology, not only to the flagship systems, but to other components, to seeing how they might use it to get some sort of predictive idea of where we're going and what could be. So that is important for us to have that broad portfolio and to have that connection, between the user, the vendor, the technology, and then just as a supercomputing center to just really just to bring this all together and to think about how this integrates into our HPC environment and how we can really advance innovation by this model and by thinking about all of these parts working together. Okay, so at the very end, I'm going to bring this back to Werner Heisenberg and to his original thought that it's really about the parts of the whole, and that's what makes all of this. And this is what constitutes the reality. It's the reality of the computing resources and services that we can bring as a community to better science and society and to really push the boundaries of innovation. And I really appreciate being able to get to share this update with you. Always interested in partnerships and in collaboration. Please feel free to reach out to me. Definitely would love a conversation. And I would really look forward to presenting in another couple of years the site update to LRZ, to all that we have accomplished in this time and where we're going next. Thank you.